Hello class and welcome to today's lesson on 7.5. Today we're going to be talking about proportions in triangles. Our objective today to use the side splitter theorem and then the angle bisector theorem, the triangle angle bisector theorem. So our central question, how do I use the side splitter theorem? And then also how do I use the triangle angle bisector theorem to find side lengths of triangles? So to start here, what is the side splitter theorem? It says if a line is parallel to one side of a triangle and intersects the other two, then it divides those two sides proportionally. So what it's stating is that right here, right, AB over BC, or flipped around as well, right, BC over AB, is going to be proportional or equal to DE over DC, right? Also, that could be flipped as well. It could have been DC over DE if the first one was flipped. So what we're going to do, we're going to use this theorem on the next page. If you need to pause to write it down, please do so. So looking here, it says, what is the value of A in the diagram at the right? So we look at this picture here. Notice the side splitter, the best way I think of it is you take each side and you turn them in to two ratios, right? We have a proportion now, a ratio equal to another ratio. So we have A over A plus 4 is equal to 12 over 18. So these are going to be proportional to one another. So what we can do, right, we can cross multiply, we get 18A is equal to 12A plus 48. Subtract 12A, subtract 12A, we get 6A is equal to 48, A is equal to 8. And there's our answer that makes those proportional, right? You could even double check, well, I should do that here on this first one, by plugging it in, right? It's saying that 8 over 8 plus 4 is the same as 12 over 18. Right, this is going to give us 8 over 12, 12 over 18. Right, if we were to reduce both of these fractions, right, these ones we could divide by 4, right, we would get 2/3. These ones over here we could divide by 6 and we would get 2/3. Notice those are the same. That's right, we did our math right. So that's a way to check our answer there. So this same process can be used. So now a corollary to side splitter dealing with multiple parallel lines. So it says if three parallel lines intersect two transversals, then the segments intercepted on the transversals are proportional. So notice in this case, right, it says AB over BC. So AB over BC is proportional to WX over XY. So we're going to use that to help us with this next question here. So it says 3 campsites are shown in the diagram. What is the length of site A along the river? So as we are trying to find this measurement right here. Well, what we're going to want to use is information that we know, right? Notice we know all of site B, so we're going to set up a ratio with that information, right? We can set that up as 8 over 7.2. What we need to do is now set up a ratio for site A. Well, that ratio, right, making sure corresponding parts are in the same spot. The X would need to be on top because, right, that's what's near the river. And then down here is what do we have in the graphs. So now what we're going to do, right, we look here, we're going to cross multiply. We get 72 is equal to 7.2x. Well, that's going to leave us with x is equal to 10. X is equal to 10. And so the length of site A along the river is going to be 10 yards. 10 yards. And if you need some time, feel free to pause. So our next theorem here, the triangle angle bisector theorem. if a ray bisects an angle of a triangle, that divides the opposite sides into two sides that are proportional to the other sides of the triangle. So what this is saying is that if AD bisects this angle, CD over DB, so notice these sides out here, a ratio of those sides is going to be equal to the ratio of those other sides of our triangle. The other sides of our triangle. So we're going to use that here in a problem to help us out here. So in this case, CD over DB equals CA over BA. Again, if these were to be flipped, then these would need to have been flipped as well. So going on to our example here. So we have this triangle, right? We have an angle that is bisected. So we know that the ratio of this side over this side, so 12 over 16, is going to be proportional to the ratio of this side of the triangle to that side of the triangle. And so, right, the 12 is in the same spot as the x, so those are the parts that correspond. The 20 goes here. And so I want to show us one quick thing we can actually do to make our lives a little simpler. Right, we could try multiplying by 12 over 16 and cross multiply and get some pretty big numbers. If we want to reduce, we can actually divide these both by 4 and rewrite this as 3 over 4 is equal to x over 20. All right, we're just going to reduce now so it makes our lives a little easier in the end. So what we have now when we cross multiply, we get 4x is equal to 3 times 20, which is 60. X is equal to 15. And so right, if we double checked, if we were to plug in 15 right there, is it going to be the same as 3/4? Right, 15 over 20 is the same as 3 over 4. So that is it for today's short lesson, right, talking about proportions in triangles.